8.7. We are going to be graphing functions using transformations. And I believe we're going to focus on these three functions. Y equals x squared, y equals the square root of x, y equals, I think I said 3, I believe there are 4, and y equals x to the third. So you need to know the basic graph of each of these, and then the transformations are going to work the same way among all 4 and every function, actually. So the x squared function starts at the origin, and if you go over 1 in both directions and up 1, and then over 2 and up 1, 2, 3, 4. So this is a squared function. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and that's how we get this. Okay. The square root function is actually the same basic shape. So instead of over 1, up 1, over 2, up 4, it's the reverse of that. And it's over 1, up 1, over 4, up 2. And that is the top half of a sideways parabola. So the x squared graph and the square root of x graph are actually the same basic shape. The square root is just the top half instead of both pieces of that parabola. All right. The absolute value of x, you plug in 1, you get 1. You plug in 2, you get 2. 3, you get 3, and so on. So it's just a line on the right side that's going up at a 45-degree angle. And then the negatives, -1 yields +1, -2 yields +2, and we get this v. That is the absolute value graph. And then a cubic graph, we start at the origin, over 1, up 1, and then over 2. 2 times 2 times 2 is 8. So over 2, up 1, 2, 3, 4, 5, 6, 7, 8. So that side sort of looks like a parabola. And it's actually steeper than a parabola. And let me draw this a little bit better. It's going to be less steep at the bottom and then steeper on the edge. And it's not actually the shape of a parabola. It sort of looks like half of a parabola, but it's between 0 and 1 on the y, it's going to be shallower. And then after that, it's going to be much steeper. And the negatives are going to be the opposite of that. So that's what an x to the third graph looks like. Okay. Let me lock all of this. Oh, you made it back. All right. So what if I wanted to take f of x and I wanted to transform it into f of x plus 1 minus 3? Well, you can perform that transformation on every one of these parent functions. So this one would be y equals x plus 1 squared minus 3. And as a general rule, anything that happens inside the function is going to affect the x-axis, and anything that happens outside the function will affect the y-axis. So this will affect the x, and this will affect the y. Which makes sense, right? The x is in there, and another name for f of x is just y. The trick is, everything on the inside is going to work in the opposite direction that you think it should. So if we have x plus 1, You would think that that moves right 1, but the x-axis works backwards, so we would move left 1. And then the outside subtracting 3 is going to do exactly what you think it's going to do. It will drop 3. So this graph will move over 1 in this direction, and then it will drop 1, 2, 3, and then you need to graph those points. Over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, and draw that graph. Okay, over here, y equals the square root of x plus 1 minus 3. So we go left 1 and down 3, and then we draw that graph. Okay. All right. Let's do it the fast way. Okay. What if we had f of x, well, let's do f of 2x. What is that going to do? Well, in this equation, that would be 2x squared. And that will affect the x-axis. So it's going to affect the width. You would think that multiplying the x's by 2 would make it twice as wide, but everything on the x-axis works in reverse. So it's actually going to divide the width of x by 2. So this point will now, instead of being -2, will be -1. And this point, instead of being -1, will now be -1/2. And that parabola is skinnier. So over here, the square root of 2x. This point is a 1. It's going to move in to 1/2. This point is a 4. It's going to move in to 2. And that sort of looks taller, but taller is not the motion that we just drew. We made it skinnier, which is kind of weird. So the absolute value of 2x, we move this point in, and we move this point in, and we get something that is skinnier. Okay. What if we wanted 2, well, let's do 3 f of x. Will that affect the x-axis or the y-axis? The x, and it's going to be 3 times taller. Or sorry, the y. It's going to affect the y. It's going to be 3 times taller. So this point is 1, 1, but I need to triple the y value to there. And this is 2, 4, and I triple the y value. That appears to look skinnier. But skinny is an x-axis transformation, and we changed the y values. So while it looks skinnier, the proper description would be taller. Okay, it's not skinnier, it's taller. What did I do? I don't know. Never seen that before. All right, so let's look at some of these problems. Oh, I didn't talk about that one. What is a negative on the outside going to do? Well, anything on the outside affects the y-axis. A negative is going to change the signs, so that will flip the graph upside down. If I have a whole bunch of transformations together, does it matter the order that I perform those transformations in? And the answer is yes, it does. So we want to perform them from the outside in. So this would be transformation number 1. These would be transformation number 2, and this would be transformation number 3. So the order would be right 1, 3 times taller, and upside down, and then up 2. Okay. Let's see if I have covered everything. Taking care of that one, and that one, that one. Okay. Let's look at this one. So we start with the function negative 3x squared plus 7, and we want to translate that vertically down 5, and it becomes the f function. So we want to take this function and we want to shift it down 5. So that would be g of x minus 5. So f of x is simply negative 3x squared plus 7 minus 5. And this becomes plus 2. So the difference between the f function and the g function is the f function is 5 units lower than the g function. Something similar. I have an f function and a g function. I know the equation of the f function is just the absolute value of x. So what is the equation of the g function? Well, on the x-axis, we have moved right 4, which would be minus 4 on the inside, and down 2. So that is my g function. X is absolute value of x minus 4 minus 2. Okay. Did I miss one? Which one's that? This one? Okay. So that 1/2 is on the outside. That's going to affect the y values. I don't think I can do it from here. I got to do it from my computer. So I need to do a vertical stretch or compression. So this point has a y value of 1, and I need to drop it down to 1/2. Or I could do, oh, I guess it will have to be that one. So half as tall would be there, and then reflect across the x-axis. If this was, say, a 3, then I would change from over 1 up 1 to over 1 up 3. And then I could do that reflection. What if the 1/2 was on the inside? Well, if the 1/2 was on the inside, you would think that the x-axis would get half as big. But the inside always works backwards, so timesing by 1/2 on the inside is going to make it wider, twice as wide. Does that help? Okay. Get to work.